Real numbers. Any number that we can think of, whether positive or negative, or say large or small, whether it is a fraction or decimal, and which can be measured, is a real number. Or any number that is not imaginary is a real number, as the name suggests. Now all rational numbers plus irrational numbers are real numbers. We are going to talk about real numbers in this chapter. So what are we going to talk about? First is Euclid's division lemma. Next, Euclid's division algorithm. Here we are going to learn how Euclid's division algorithm we are going to apply to find out HCF of two positive integers. We'll be applying Euclid's division algorithm to find out this. Next, we will look into fundamental theorem of arithmetic. Where we are going to concentrate on composite numbers, so we will be revisiting irrational numbers, and we see how certain numbers can be proved as irrational. So here we are going to look into the proof, and at the end we are going to revisit rational numbers, mainly we'll be concentrating on decimal expansion of rational numbers. So the rational numbers which we can represent in the form of p by q, where p and q are integers, how we can represent them in decimal form. Euclid's division lemma. Let us first state that. What does it say? It says given positive integers, let us take a and b, then there exists unique integers q and r. Satisfying the lemma, that is a equal to bq plus r, where r is greater than or equal to 0 and r is less than b. This is not new to us. We have been using it for ages. Let us try to understand that. Let us take two numbers, say 15 and 7. Let us divide 15 by 7. 15 divided by 7, it is 2 times, so 14 and remainder is 1. So this is dividend, this is quotient, and this is divisor, and this is remainder. And we know how to represent all these things together, that is dividend equal to divisor into quotient plus remainder. So let us take, now we can say 15 is A, 7 is B, 2 is Q, and 1 is R. So here 15 equal to 7 into 2 plus 1. So 15 is A equal to B, Q plus R. So the way we represent is the same as Euclid's division lemma. So Euclid's lemma is the formal statement of this method. Now let us try to understand what is meant by Euclid's division algorithm. An algorithm is can say a series of well-defined steps that gives us a procedure to solve any problem, solve a problem, you can say. Now here in this chapter we are going to use Euclid's division algorithm to solve or to find out the HCF of two positive integers. Let us take two integers as 180 and 75. So let us try to represent these two integers using Euclid's lemma. So let us take this as A, this as B. Now 180 divided by 75, this is 2 times 150, so remainder is 30. So here A equal to BQ plus R. A is 180 here, is equal to B. B is 75 into Q. Quotient is 2 plus R is equal to 30. This is the first step of the algorithm. Now in this case, if the remainder, this becomes 0, then the divisor, or here it is B, or here it is 75, that will be the HCF. If divisor is not 0, then we have to continue this step, taking 75 as A and 30 as B. So for the next step of Euclid's division lemma, we will be taking 75 as A and 30 as B. Now let us write 75 equal to, next 30 into 2, 30 into 2, 60, 75 minus 60, so it is 50. So this goes here and this goes here. Now here also remainder is not 0, so we need to continue this. So this becomes A, this becomes B. So now 30 equal to, so B, so 15 into, this is B, 2 plus 0. So in this case, the remainder became 0. So here the divisor, or B is 15. So this is HCF. So the HCF of 180 and 75 is 15. So this is how we can find out HCF of the numbers, positive integers, using Euclid's division algorithm. This is the algorithm. We use Euclid's algorithm to solve problems. So this is how you solve this problem. Now to find HCF of two numbers or positive integers, let us take C and D, where C is greater than D. So we need to find out the HCF of these two numbers. Now, step 1. Step 1. Apply Euclid's lemma for C and D. Lemma on C and D and get unique integers Q and R. So that is C equal to DQ plus R, where R is greater than or equal to 0 and R is less than the divisor, that is D. This is the step 1. Step 2. Now, in the first step we got R. Now if R equal to 0, then D, that is the divisor, is the HCF. That is the end of it. Now if R is not equal to 0, R not equal to 0, then apply the lemma on, now not on C and D, now on D and R. Next step. Now continue this process, that is the step 2. Continue step 2 until R equal to 0. So when R equal to 0, then the divisor at that stage is the HCF of C and D. So this series of steps to find out the HCF is Euclid's division algorithm. Now let us solve some problems. Problem number 1. Using Euclid's division algorithm, find the HCF of 504 and 1188. So if A and B are two numbers, then if we divide A by B, we get two more integers q and r such that a equal to bq plus r. This is Euclid's division lemma. Now let us take a as 1188 and b as 504. So now we have to write this in Euclid's lemma, that is 1188 is equal to 504 into the quotient. Let us find the quotient. So 1188 divided by 504, so this will go 2 times, so 504 is 1008, so 081, so it is 180. So this is quotient is 2 plus remainder is 180. So this is not 0, so 504 is not the HCF. So we have to get into the next step. So here 504 will come here, that is equal to 180 will become the divisor now. 180. Now we have to decide again. So what is the quotient? So it is now 504 divided by 180. So this will be 2 times, that is 36441. So this is the remainder, this is the quotient. So it is 2 plus the remainder is 144. So again remainder is not 0. Let us continue. So 180 equal to, now this becomes 144. Of course 144 will go only once in 180. So 180 minus 144 is 6. 7 minus 4 is 36. So remainder is 36 here. So still remainder is not 0. So go to the next step. 144 equal to 36 into, now 144 divided by 36. So let us take 4. So now it is 4 times, that is the quotient, plus remainder is 0. So when remainder is 0, the divisor is the HCF of the two numbers that what we have taken here. So this is the HCF. So HCF of 504 and 118 is 36.